This building could have killed tens of thousands of people.
In 1977, Citicorp Bank built the 7th tallest skyscraper in the world. It was a symbol of corporate confidence in a New York on the brink of financial collapse. The safety of the structure, like any tall building in Manhattan, was taken for granted by the thousands of people who crowded into the area. What they didn't know then was that the tower had a major design flaw.
First time I heard the story, I knew it was a good story because it began with a dramatic scene in the Citicorp boardroom when a structural engineer came in to tell them that this spanking new beautiful tower had a flaw in it. And not only that, it had a flaw so bad that it could wipe out 18 blocks of Manhattan if a high wind came along.
In the worst case scenario, this was not a building that was going to just simply crumble and fall down. This was a building that was going to tip over in the wind. And it would cause domino. It would cause the next high-rise and the next high-rise to fail. And how far that would go? Probably the most extreme that I heard was that it could go as far as Central Park.
Nobody at Citibank really wanted to believe that this beautiful work of architectural art, this masterpiece of real estate investment, was so fatally flawed. They brought in a man who was then the expert, the world's leading expert on structural design in tall buildings.
The engineer at the table stood up his notebook and dropped it and said, "It's 70 miles an hour for 5 minutes. There goes the Citicorp building."
If the wind blows, and that got their attention.
The extraordinary chain of events which led to the discovery of the building's weakness began with a phone call out of the blue to the engineer who designed it, William Lemessurier. The call was from a student in New Jersey whose professor had told him to write a paper on the Citicorp Tower.
The professor said the engineer should have put the columns in the corner. That's the way you should do any building. And I explained to the student in a telephone call that he could tell his professor there was a reason for this, which was the fact that there was a church that owned the land at the corner, and we couldn't put a square building up with columns in the corners. We had to move them so that the church could build a new building in there. And that's why it has this unusual structure.
You know, I call this Citicorp vodka. Tell by the bottle. It happens to be very good vodka. My first thought was to cantilever one corner of the building over the church. And I asked Bill Lemessurier if this was a feasible thing to do. How about a twist of lemon? And he said, yes, he thought so. And then as we worked on the thing, we somehow came to the conclusion, why not cut the other corner off of the building? And in that case, why not cut all four corners off of the building?
It's as if you had the legs of a chair in the middle of the chair instead of on the outside along the perimeter. If you were to strip away the skin of the Citicorp Tower, you would find not your standard up and down pillars and columns, but a series of gigantic chevrons, V's, that stretched 8 stories, starting at the first floor and going up to the 8th floor, and then another one above that.
It was in the chevrons that the design problem lay. These diagonal struts, which are clearly visible inside the building, were part of an ingenious system to brace the structure against the power of the wind. In response to the student's call, Lemessurier made further calculations of the chevron's performance. What he found surprised him.
In the process of doing the numbers, I found out a discovery that the forces were sensitive to the wind direction in a way that was not common way to think for most people. Certainly the building code in New York didn't address such matters. And I began to worry that, in fact, I was almost sure at that very moment that probably no one ever thought about that.
Accommodating the church underneath led them into this eccentric design, and the eccentric design, apparently, was the root of what became the greatest disaster never told.
The vulnerability of the chevrons would not have mattered so much if it hadn't been for the way they'd been constructed. It was this which brought the building closer to catastrophe.
These diagonals intercept 8 floors. And there were joints that were made in the construction of the building because there have to be. You don't get a piece 8 stories high and put it all up at once. It comes in sections. So there are splices that were made every 2 stories. So there were 5 splices made. The original design had been based on those being fully welded, but then I found out that those things had been changed.
In the course of the construction, a change was made to that, apparently going through all the proper channels, where the subcontractor requested an alternative to bolt those connections instead of welding them. And conceptually, there's no problem with that approach.
Lemessurier went to New York to check the drawings. His concern now was that the bolted connections in the wind bracing might be vulnerable to the wind forces in a way welded joints would not have been.
If it had just been the first mistake, it would have been more borderline and probably a more agonizing decision to make. It might not have been necessary to fix anything because there's always a factor of safety in what you do. But what I found out at that meeting in New York, all factors of safety were gone.
We got a call saying that he wanted to come and discuss a problem which he'd identified. And it certainly wasn't discussed, to my recollection, over the phone. We knew it was an urgent problem. The structure evidently was not as strong as expected, so we had to go back over our calculations to say what was the wind speed that this new structure with the reduced strength bracing members, what loads could that structure withstand?
The figures from the wind tunnel confirmed the engineers' worst fears.
Well, I had been up in Canada and had collected all the information that I could get from anybody in the world, and I felt I had to go into a retreat and think it all through. And finally came to the conclusion that it was a terribly serious matter. That was very frightening. So said, I'm going to go and have to do something about this, because we got a problem. And so I left and came across in the boat and got in my car and drove. I was shocked at how bad things were. The building had a probability, which you might say was 50-50, of falling down completely, breaking off in the middle of the building and going kaput with a storm that could come statistically once every 16 years. 16 years. I'm only 52. It means in my lifetime this building could fall over. Certainly, I was sufficiently convinced in my numbers that it sooner or later was bound to.
That was the point he told me of the flaw in the building. Well, I can tell you I was a bit shocked. I'm not sure that the seriousness of it penetrated all the way at that moment.
Bill described the issues, the problem, the potential for the building literally failing. It's probably the scariest moment of my entire life.
The architect and the engineer now had to inform the chairman of Citicorp, Walter Wriston, that the $175 million symbol of company pride, already nicknamed Walter's Whistle, was fatally flawed.
Wriston was stoic about it and behaved extremely well. And it took a big load off of my mind to have that kind of reaction, because they were being supportive. They are not blaming anybody, they were being very supportive, and we decided right then and there that we had to do something and do it immediately.
I said, I need your help. There's something very seriously wrong with this building, which is fixable. But it has to be done. We've got to move fast. The hurricane season is coming. This is the beginning of August. And sometime in August and September, a big storm might come, and it might be the one that would do us in. So we got to start at once. There were two sets of data from the wind tunnel. One was if the wind was just blowing on this building as an ordinary building, but this wasn't an ordinary building because we had initiated in this building one of the remarkable innovations in tall building design by adding a system of machinery at the top which counteracts the motion of the building and therefore reduces the forces of the building and the amount it deflects. And it was really done for people's comfort. It wasn't done for the safety of the building. But nevertheless, I realized that it could help the safety of the building.
I talked to a vice president at Citicorp, Henry DeFore III, who was assigned to deal with pesky young journalism students like myself, and they brought me up to the roof. He gave me a tour to show me the tuned mass damper. What a thing. What a thing.
Right in that area here, you also have the TMD, which is the two-mass damper, which is a 400-ton concrete block that during wind conditions elevates and maintains the sway of the building. The building swaying one way, the block will follow it, and so as the building sways back, that's where the dampening effect takes place. It doesn't actually counteract the sway of the building because you would just snap the steel structures right in half if you did that.
It goes from one side, you hear going, and then it goes back to the other side, and then it just keeps going back and forth, back and forth. Two years ago, we had a storm that was really, really bad. A lot of the places over here got flooded by the river, and a lot of the people left the building because the building was swaying a lot. The two-mass damper was running. I was up here. I was maintaining it, and it was so bad that we had the doors on the panel were swinging, and the doors were actually hitting me as I was controlling the TMD. And we also had puddles of water coming in from all the rain. And in the puddles, we had waves. So that's how bad the building was swaying.
Lemessurier's hope that the damper might be considered as part of the building's protection against storm winds was dashed by the consultant engineer acting for Citicorp.
He said, I can't, as a matter of principle, count on those. So I have to take the point of view that we're relying only on the bolted joints. And therefore, there is a crisis, and therefore we must have an evacuation plan for the area until we get it fixed.
A friend of mine had heard it from another friend of ours who worked at the Red Cross, that they had been involved in this incredible top-secret project to map out all the activities of people in Midtown Manhattan around the area of the Citicorp Tower. So they actually wanted to figure out how many people were on the ground around there to know how many they'd have to dig out.
Most of what we would do would be working hand in hand with government, with other agencies. There would be full public information, but not on this one. It was very clear right from the start that this was to be done confidentially, that it was being handled on the highest levels of industry and on the highest levels of government, and that our work was to be as confidential as possible.
The amazing thing now as I read back on these notes is the sort of stone-cold lies told by the bank. I asked Mr. DeFord about the presence and involvement of the Red Cross in this job. And he says, I don't know of any involvement whatsoever with the Red Cross. They did a survey of the streets around the... Doesn't ring a bell with me, he said.
Did was design what we were calling a marketing survey, and one of the Citicorp officials recruited members of his church to be recruits that we trained in the morning. We turned them loose with their clipboards, and they went door to door to these commercial high-rise residential buildings and cataloged it street by street, block by block. Working in this confidential environment at Citibank,
It was a tense time. And we were all watching the weather reports and hoping, hurricanes would come along the coast, because we do get a lot of them, up in this area.
At the same time, the engineers were hunting down the manpower and materials to strengthen the wind bracing at each of the 200 suspect connections. Lemessurier designed H-shaped steel reinforcement plates, which would have to be welded in place while the building was unoccupied at night.
We decided as long as we're fixing these things, we're going to make the connections so that this building will not fall down in a 1,000-year wind. And within a day, we had meetings with the people that had the capability of mending this building and finding that there was steel available and so forth.
Lemessurier now realized that the unusual structural design of the building could be made to work to their advantage.
The wonderful thing, you see, when we were designing the building with Hugh Stubbins, having a big ego myself, I loved my diagrams for these diagonal members. I would be very pleased to have them show on the surface of the building. But Hugh Stubbins put the kibosh on that from the beginning. No, no, no. This was a blessing in the end, because these joints were all therefore accessible. And the actual mobilization to get at them and fix them was relatively straightforward.
The work was to be done at night and as secretly as possible, as soon as the office staff had left the building.
I knew that all we had to do was strip off the gypsum board fireproofing and we could see these joints. The actual fix, in most cases, was very simple. It was a matter of getting some very thick steel plate, a very high thick, 2 inches thick, putting pieces on both sides of the steel diagonals across the joint which was held together with the bolts. And within a day or two, the first connection started being put in place.
We had between 21 and 23 welders working at a time, and on weekends we would have a few more. They worked every night and Saturday and Sunday. When you weld, particularly when you weld as much as we were welding, you produce a lot of smoke. You simply couldn't live on a floor that we were welding. And I think that the people living in the building would have become very upset if they understood exactly the dimensions of the problem.
We had flown into New York, my wife and I, in a plane that had made available to us. It was a private plane. And the pilot had to skirt some thunderstorms and ended up coming in close to Manhattan, and there was the building, sparkling.
So by the time people actually started walking into the building, it was back clean and normal, and everybody was working again. No smell of welding. No one except the people who had been told understood exactly what was going on.
Oh, I'd come back from a busy day, and my wife said, well, the New York Times has called, and they want to talk to you. And I said, oh, my God, I don't need that. Well, I mixed myself a martini and finally dialed the phone. 6 o'clock. All of a sudden, I get an answering machine that said the New York Times went on strike at 6 o'clock tonight, and it's closed for foreseeable future. Wow. Anyway, that was a great blessing. And all the newspapers in New York, it turned out, went on strike at that time, and stayed that way until October.
If the newspapers hadn't been on strike, I dread to think what would have happened. It would have been pure hell, I think.
As the nightly welding continued, the building became progressively stronger. But on Friday, September the 1st, the weather watchers at the Rockefeller Center broke the news that everyone had been dreading.
We had 3 different weather services giving us information every day on the approach of any kind of wind over 40 miles an hour. So we got the information that there was a storm coming up the Atlantic. And it was on a track that had the potential of coming straight up to New York.
Okay, we figure that the beginning of the hurricane conditions will start there anytime after dark this evening.
Friday morning, we had an enormous meeting because everybody was concerned. Do we evacuate the neighborhoods? But at the time we got into our meeting and talked for an hour or two, we got more word from the weather service. The storm has shifted path and is going out to sea.
I guess when you have that many thousands of lives potentially at risk, you don't really have a choice. You have to own up to it and do it. The unions cooperated, the city cooperated. I always felt that Bill was heroic. It was just a pleasure to do. Sometimes, I guess, emergencies make people behave better. And everybody did a wonderful job. There were no bad guys. Everybody was wearing a white hat. My memory says that we did the whole job from the very start to the very end in 8 weeks, and that we managed, and I know this is disputed, $8 to $10 million in that time. Now, it takes a lot of work from a standing start, no preparation, to spend $10 million, $1978 in 8 weeks.
I don't think there was any blame. Not that I remember. There was no recriminations. There was some negotiations about who would pay for the damages. And I think LeMaisure's insurance company paid a bit of money, and I don't know how much it was. We as architects didn't have to pay anything. And I always thought that Citicorp behaved in a very professional and wonderful way about that. They didn't sue anybody. It was all handled by negotiation.
There's been a whole evolution of standards and understanding of the wind that's gone on over the last 40 years. And one wonders. I don't mean to speculate. I'm not going to pick any examples, but there might well be buildings that were built from the old days that have never yet been subjected to the wind that would knock them down. And they might go.